Hi everyone, this is Nafish. Today we are going to work on logistic regression model. So these are the steps I'm going to follow. We are going to import the data set from Seaborn library. There are some built-in data sets in Seaborn, and then we are going to separate the feature variables and target variables, then split the data into training and test, and then we are going to build the model on the training data set, and we are going to evaluate the model using the test data set. Okay, so first thing first, we have to import numpy as np and import uh, Seaborn as SNS. Okay, run it, and then we have to import the data, right? So data is equals to calling the Seaborn library SNS dot load dataset, and then we are going to import the RDS dataset. Okay, so we run it, and let's look into the data. So we see we have like 5 columns right here and 150 entries. Okay, so basically we are going to use all these numerical values to predict the species. Okay, before we get into the other topics, we just need to look into the data a bit. Okay, we just need to understand the data, and we are going to do some plotting, and then we'll dig into the logistic regression model. Okay, so first thing first, let's see whether we have any null values. So we have the data.info. If we do that, we can see we have 150 entries and 5 columns, and we do not have any null values in any of the columns, right? And 4 of the columns are float values, one is the object. Okay, so since there is no null values, we don't have to worry about the null values. We can just go into the next part, which is we can see how many different types of species we have. So we can say data, then calling this species column, and then do a value count. So value counts and run it. Okay, so we can see like we have different types of species: Setosa, versicolor, and virginica, and each got 50 entries. Okay, so next we can do some plotting just to better understand the data. So what we can do is we can call the Seaborn scatter plot, and then let's say x is equals to sepal length, and then y is equals to sepal width, and then we have the data as data, and let's say who is the species. Okay, okay, so let's plot this out. Oh, okay, I think I made a mistake here. It's going to be length. Okay, okay, so from this plot, it's kind of hard to understand the relationship, but we are this is just an example, right? For whenever we're doing any regression modeling, we just need to interpret the data a little better, right, before we go in advance. So here we are plotting the sepal width and sepal length. Let's plot petal length and petal width, the other 2 columns. Okay, so petal length and petal width, and let's see how that is located. Okay, so here you can see like there is some relationship. You can just say like whenever we have like the petal width for Setosa species, it's kind of falling in this bucket. Then we have the petal length. This is also kind of, you can isolate this data from the other one and also from this guy, right? So this is kind of useful information, but we usually look into the data first before we go deep into the model. Okay, what we can do next is like we can do a strip plot, same like this. I'm just going to show you right here. So rather than the scatter plot, do a strip plot. Okay, and x, let's say x is species. Okay, and then do the plotting. Okay, so here you can do a strip plot as well, and basically what it is saying, like the petal width for the Setosa species is just within this bound, then the versicolor is within 1 to 1.5, and then the virginica is like 1.4 to 2.5, something like that. Okay, so for any model, like you can just do different types of plotting and try to interpret the data a bit. We can also do another plotting from the Seaborn library, which is sns.heatmap, and basically doing the correlation plot. So data dot core, and this is just going to give us how the columns, or all these columns right here, which is going to be our target variable, they are related. Okay, so right here you do a correlation and run it, and let's do an annotation as well, and it's true. Okay, and run it. Okay, so you can see like there are some highly correlated values. So this petal length and petal width, this is kind of very much correlated. The max value can be one. As you see, these are like um, correlation with itself. Okay, the mutual correlation. So you see sepal length right here. All these diagonal values, these are kind of correlating with the with itself, and this is giving you the max value one. But right here 0.96, this is petal width and petal length, so this is kind of very much correlated. And there are some negative numbers, which means like if one increases the other might decrease, but this is kind of the numbers are not that much high. So this is related, but it is in a inverse order. Okay, so from the correlation matrix, basically we have all these feature columns or predictant, and we can just try to see the relationship. Okay, so let's get into the data again. Let's look into the data first. Here, all these numerical values, this is our feature variable, or we can say like this is the predictors. Okay, so we are going to use these variables, use these columns, 1 2 3 4 columns, to build the model, train the model, and then do some predictions. And the prediction and the target variable, that is the species variable. So basically the model is going to say, after inputting these parameters, which is what species. Okay, so next thing is we need to split the data, right? So let's separate this input and target variables. Okay, so the feature variables, let's say x is equals to our data, and then um, we have sepal length, then sepal width, then we have petal length, and then we have petal width. Okay, and you see we are using a there is two brackets in the beginning and the end. Basically we want to have the data in a two-dimensional format. Okay, let's run it. Just going to show you. So x is nothing but all these input or the features, but we want to have in a two-dimensional. So basically if you do the values here, then that's going to give you an array. Okay, so to the values and run it, and then look into the x. Okay, and this is basically the array. From the data frame, we're just converting this into an array. And if you look into the dimension, this is two-dimensional. Okay, let's do the same thing with our target variable. So y is equals to data and then species. Okay, run it, and then we can also do values here. Okay, and then run it, and then look into the dimension of y, which is going to be single dimension. Okay, right here. Okay, so we have to keep this in mind, like the inputs or the features is going to be two-dimensional. Okay, now we have split the data, right? So we have our x and y variable. Now let's scale the data a bit. Before scaling, what we need to do is, like, we have 150 entries, right? So we are going to use most of the data for building the model, but we are going to keep some of the data which we are going to use in later in this video, just to verify our model, like how the model is doing in the prediction. Okay, so what we need to do for that is split the data. Okay, right here, split it, and then we're going to do some predictions on that. We are going to use that later for some validation. Okay, so let's import sklearn. Okay, scikit-learn, and basically from after importing that, this is where we have the logistic regression model built in. So import that, and from sklearn dot model selection, import train test split. Okay, so run it, and then what we need to do is x train. We're splitting the data here. X train, x test, then y train, y test. Okay, and then you call that train test split. Okay, input's going to be x and y, and then test size is, let's say, 0.05. So we are just going to keep 5% of the data for testing purpose, but we are going to use the 95% of data to build a model. Okay, so run it, and this is just like splitting the data. You see, okay, there is some error here. Oh, test size. This is going to be test size. Okay, Now run it. Okay, and then look into the X train. Okay. Okay, so this is, you see, there is nothing but just splitting the data. There is no operation rather than just splitting the data set here. Okay, now after we split the data, we are going to do some scaling on this data. Okay, so uh, from scalar import from scalar dot preprocessing. Okay, import standard scalar. Okay, you run it, and then let's say standard scalar ss, we are assigning this object to ss, so standard scalar. Okay, and basically what this is going to do, you see we have all these values here, right? So this is going to scale the data into zero mean or near about zero mean and unit standard deviation. Okay, just going to show you that in a bit. So you run it, and then uh, let's say ss dot fit transform, and then our data is x trained, right? We are just going to use our training data set. Okay, and let's say you assigned it to x scaled. Okay, so you scale the data. Okay, you run it, and let's look into the scale data. Okay, so x scaled, let's look into the first column. Okay, so one, and run it. So you see there is some scaling. It's not like before, scaling applied, but as I mentioned, it's going to be zero mean. So let's look into the mean. It's close to zero, you can say, and the standard deviation is going to be one. So let's look into the standard deviation. This is one. Okay, so this is can happen. This is true for all the other columns. Let's look into the second column, for example. Okay, and the mean is, it's a very small number, which is very close to zero. Okay, so the scaling is just kind of uh, scaling the data in such a way that the data is zero mean and a unit standard deviation. Okay, so we are done with the scaling of the training data, but we also need to scale the test data, right? So let's do that. And for test data, we are just going to do scaled test. Okay, fit transform, rather than doing the fit transform, we're going to just transform the data. So why we're not using fit transform here? Because we are going to use the same mean and standard deviation we got from the other the training data, right? We are not going to calculate the mean and std again here, okay, for the testing data, because then this data will be biased. Okay, we just need to keep in mind for testing we're just going to transform it. We're not going to fit and transform. Okay, so this let's run it. Okay, so we are done with the scaling. Right now let's build the model. So from scalearn dot linear model, scalearn scalearn dot linear model. Okay, import logistic regression. Okay, run it, and then assign this to an this object to a variable. Let's say logistic regression is assigning this object to lgr. Okay, and next thing is going to, we need to fit our data to this model. So lgr dot fit, and then x scaled, right? X scaled. Okay, and this is, let's say this is our model. So model is equals to this guy. Okay, x scale, and then we have the y train, right? Okay, so run it. So we are done with building the model. Okay, now what we can do is we can do some prediction. Okay, so let's say model dot predict. Okay, and remember we have some test data, right? So x test scaled. Okay, right here x scaled. Okay, so x scaled test. Okay, this guy, and if we run this, so this is too many. I don't think we had this many data. I think I made some mistake here. Oh, this scale test, this is going to be, rather than train, it's going to be test. Okay, so this is test, then run, and okay, so our model is predicting, after getting the input test data, this is predicting the output. But remember, we had that white test as well, which had the ground truth, the real, the true values, right? So we see, let's run it and then compare. Okay, so okay, so I think all the values are matching here. Okay, so the data we stored to verify our model is kind of like, and matching with the prediction, model prediction. Okay, so pretty much it's kind of doing a great job. Also, we can do one thing: model dot predict probability. Okay, so this is going to give us the probability. Okay, so let's say scaled test and run it, and I think we can do some rounding. So np dot round, and up to, let's say, two decimal places, and then run it. Okay, so here it is. So it predicted setosa, okay, with 91% probability, but there is like 9% probability it could be versicolor. Okay, same with the other one, versicolor, when it predicted versicolor with 96% probability. Okay, so there is a threshold we have to keep in mind, threshold of, I think, zero point 0.5. Okay, so here you see it's 0.76, 0.99, 0.32, 0.68. This was really close right here. Okay, so this is how the model is predicting. There is a probability percentage on each of these predictions. Okay, so this is a kind of very basic logistic model, logistic regression model. Hope you guys learned a lot from this video. um, and this is like, in future we are going to do some we are going to use some different data and do some more modeling. Okay,